Okay, on to page 11. We've got some more graphs to plot here, and they've given us some tables to figure out the coordinates for. Okay, so we've got the equation y equals 2x minus 4, so that literally means the y coordinate is equal to 2 lots of the x coordinate minus 4. So we're going to substitute these x coordinates in place of this x and see what we get as an answer for y. So they're all positive this time, so there's no point starting with the positive ones, apart from 0, that's neither negative nor positive, but we'll start with that one. So 2 lots of 0 would be 0, take away 4 would give us minus 4. Okay, 2 lots of 1 would be 2, minus 4 is minus 2. 2 lots of 2 would be 4, minus 4 is 0. It's probably starting to see the pattern now, it's going up in 2s. Let's just check that with this last one. 2 lots of 3 would be 6, take away 4 gives us 2. So if we draw this line, plot some coordinates first, so 0, negative 4 is there, 1, negative 2 is there, negative 2, 0, 3, 2. There we go. Okay, it's always a good idea to write down the equation of a line next to it, especially if you're going to put multiple lines on the same grid. Okay, next one. Y equals 3x plus 3. Change colour for this one. So we're going to times the x coordinates by 3 and then add 3. So 3 times 2 is 6, plus 3 is 9. I'll come back to this one in a minute. 3 lots of 0 is 0, plus 3 is 3, and 3 lots of negative 1 is negative 3, plus 3 is 0. So you can see the pattern in these y coordinates is that they're going up by 3 each time. And I haven't mentioned this already, but you might have started to notice that this constant difference we get in the y coordinates on a linear graph is always the same as the number in front of x. This number has a fancy name, it's called a coefficient. It's always the same as the coefficient of x. So this one was going up in 2s, so we've got a positive 2 there. Okay, so you've probably figured out that this missing x coordinate here is 1. So let's plot those on. Stops moving. There we go. And I'll just write the equation next to that. Okay. Does the point 2, 5 lie on the graph of y equals 2x plus 5? Well, remember that an equation links the y and the x coordinate. All we need to do is put this x coordinate into this equation and see whether it gives us a y coordinate of 5 when it comes out. Okay, so we're just going to substitute in x equals 2. So 2 times 2 would be 4, plus 5 would be 9. The y coordinate for an x coordinate of 2 would be 9. So the answer is no, but 2, 9 would, if you really want to show off. Okay. Number 3, Dale has created a table of values for the function y equals 4x plus 3. Do you agree with Dale? Give reasons for your answer. So just a case of checking that he's done this correct. So all we need to do is times all of these x coordinates by 4 and then add 3 and see whether we get these y coordinates. So 4 lots of 2 would be 8, plus 3 would be 11. So that one's right. 4 lots of 1 would be 4, plus 3 would give us 7. 4 lots of 0 is 0, plus 3 is 3. 4 lots of negative 1 would be negative 4, plus 3 though would be negative 1. So this is where he's gone wrong. He's taken away 3. 4 lots of negative 2 would be negative 8, plus 3 should be negative 5. Again, he's taken away another 3. So he clearly has an issue with negatives. Okay, and the last one is kind of a real-world linear graph. And it says the rule multiplied by 1.6 can be used to convert from miles into kilometres. Complete the mapping diagram below. That's a fancy name for something that just simply means change miles into kilometres. So here, this is just telling us that m has been times by 1.6 and we've ended up with 1.6m. So it's just in letter form now. If m was 1, times by 1.6, and we would get 1.6. Sorry, just zoom in a little bit. M was 5. 5 lots of 1.6 would be 8. So 5 miles is 8 kilometres. It's a very good conversion to know. 10 times 1.6 would give 16, and 20 times 1.6 would give 32. And then we're going to plot those on the graph to create a conversion graph. So just zoom out so you can see those. So 1 mile is 1.6 kilometres. Now that's very small, too small to fit on my graph actually, so I don't need to do that one. 5 miles, 8 kilometres. So that's there. 10 miles is 16 kilometres. There. And 20 miles, 32 kilometres. Okay. And unsurprisingly, it goes through 0 because 0 miles would be 0 kilometres.